One of my students asked how we make this flag effect on Yuka Takahashi's website. So how do we go about making something like this? Well, I've just quickly made my own version that looks something like this. So how do we go adding this movable 3D flag onto a page like this? So what we're going to be using is a library called Three.js. Now Three.js is used in lots of different kind of sites. You can actually look through all of them here. I've just quickly downloaded this. It's quite a big download. We'll talk about how to do this in a second. But I've also just quickly made my own version of this site. So I've quickly just added some HTML. Here we go in the top corner, in the header. We've got a navigation up here, and we've got a section class flag. So my flag is going to go in here. Technically, I could just add an image and be done with it, but I want something that moves. I've also added the three.min.js file in here. So this is from the downloads. And I've also got my own flag.js. So flag.js at the moment is completely empty. We're going to add our code in here. So how do we go about doing this? How do we work with Three? Now, luckily, as part of Three, it gives us some documentation that we can actually use to create what's called a scene. Now here it says before we start, before you can use Three, you need to display it somewhere. We've got a HTML file and we've added Three.js. We've just done it in here. Now Three.js is quite a big file. If you're using the SciPy editor, what I would recommend in settings is setting this to true, just to kind of speed things up. It's a pretty big file. We might as well kind of optimize things. So how do we actually make a scene? Well, here we have Three.js and then our code goes below it. Similar to what we've done in our HTML, we've got our Three.js and our flag.js. All of our code is going to go in flag.js. So how does Three do things? Well, what we can do is actually just grab some of this code and we'll alter it as we go. So the first thing we're going to do is just take all this code from here. We actually want to make a scene with a camera and then render it. So I'm going to copy this code and I'm going to put it into my flag.js. There we go, just pasting it in. Now, next, there's some more info. It gives us a bit of more information on here. If you do want to read this, I would definitely recommend this. Further down is this. We've got some geometry, a material, and a cube, and we're moving the camera position back. I'm going to copy this one and paste it under here. Now, at the moment, we don't have anything in here, but if we scroll down the page, you'll notice this black area starts to appear if I scroll down. Now, eventually, we want this area to be in the middle of the page, not below it. We'll talk about that in a second. But if we look again back on creating the scene, I'll scroll down. It says rendering a scene. So I'm going to take this code and I'm going to copy it and I'm going to put it in underneath. There we go. Now, if I scroll down again, what we should see is this cube appear. Now, this cube comes from this geometry. This color comes from this color over here. We add them together. We add it to the scene. And this camera position is 5 away. Now, if I scroll down even further on this page, you'll see that you can animate this cube as well. So here, I'm going to take this code. Now, I'm not going to paste it underneath. It says it needs to be in this animate function. So what do we want to do? I want to put it in this animate function. I'm going to add some space and paste it in here. And there we have a cube that spins around. So this is the basic thing for creating a scene. I've copied and pasted anything. I haven't just done things. But what I want to do is have this on the main part of the page, not underneath. At the moment, what is happening is this is being added to the body of the page. So this is essentially going, well, after this, and after this. So currently, our flag is pretty much here on this line. But we want to put it in this section tag instead. So I need to update my code. So I'm going to pick this section tag and add my cube to the section tag. So in my flag.js, the first thing I need to do is pick that thing that I've just said. So here, I'm going to pick this section with a class of flag. If I was in CSS, I would do it down here as section.flag. In my flag.js, I'm going to add some space and I'm going to say, well, right at the top, I'm going to pick a constant called section, because it's whatever I want to call it. And here in my document, I'm going to do something to this document. I'm going to do a query selector. Basically means something like CSS and round brackets to run this. And in quotes, what I'm going to say is section.flag. So here I've just picked this section. I'm not doing anything with it just yet. But what I can say is instead of this being appended or added to the body of the page, I'm going to get rid of this document.body and replace it with section. So now my section, if I scroll up and down the page, you can see my links up here, and technically there's some text up here as well. It's in the main part of the page. Now by default, in 3, as you can tell, the background is black. But what we want to do is make this see-through. Now, each one of these things where it says new 3.scene, new 3 perspective camera, WebGL renderer, has a page in the documents. Now I'm going to look at the WebGL renderer. So in here, what we can pass in is some extra things. Now what I want to pass in here is an alpha channel, basically make it see-through. By default, it's false, therefore we see a black background. So in my code, I'm going to add some extra info into my WebGL renderer. To do that, I'm going to put my cursor in the round brackets and add some curly brackets. Now I'm going to space these out just to make this easier to read. So press an enter. And what do I want to put in here? Well, some extra info is all about, well, in here, they call it alpha. We don't want alpha to be false. We want it to be true. So I'm just going to say alpha is true. And now we can see this has this background disappear. Now I can also add in some anti-alias. It is a little bit pixelated around the edge of this cube. And in here, there's another thing I can add in. I can look through these options and say anti-alias is false by default. I do want it to have this kind of crispy edges. Here I'm going to do a comma after true, add a new line and say anti-alias is true. This basically smooths these edges of the lines and I have this cube now spinning around the page. So I've set up my main part of the page, only at the moment I have this cube in green, which is not what I want. So where is this cube of green happening? So it's happening down here. So I've got a geometry, which is a box, hence this box. I've got a mesh basic material, which is colored green. Let's just change that. Well, at the moment it has this color of OX00FF00. This is basically like a hex value, except rather than the hash at the start, it uses OX. And this is just part of GL, WebGL. So I'm just actually going to add some tidying up here. I'm going to space these things out just to make it easier to read. There we go. Add some space in there. I've got my geometry, my material, and my cube. So if I want to change the color of this from green into something else like red, I would just say, well, what is a red color? Well, I could use like hash FF0000. And all I'd do to change that is not just hash OX. Instead, I'd put FF0000. So that is now in red. Now, this is just a solid color. We'll add some texture to this a little bit later. Now, the first thing we want to do is not make this into a box. We want to make it into a flag. Now, a flag doesn't have a name. It's actually just a kind of flat panel. But if we go back to our WebGL renderer, as part of the documentation, if I scroll down this sidebar, I'll get lots of things I can add in my geometry section. I've got a box geometry, which looks like a box. I don't want it to be a box. What do I want it to look like? Well, is it a circle? It's not quite a circle, but it could be. Is it a cone? Nope. I could just click through a lot of these things and see what comes up. So there's a few things in here that we could use. The one that I'm actually going to use is called a plane geometry. So there we can see this is kind of like a flat panel. So instead of it being a box geometry, instead I'm going to change this to be not a box geometry, but a plane geometry. So now we have this panel that's spinning around in thin air, which is fine, but we might want to give it a size. So if I go to the plane geometry page, you'll see further down that we can pass in some more information as part of this. A width, height, how many segments in the width, how many segments in the height. So let's give it a width. The width that I'm going to give it is, well, I want it to be flag shaped. So maybe let's make it 5 across. There we go. And how high? 3. So this kind of feels like a flag shape, kind of looks pretty good. Now, what we want to do as part of the flag is actually move bits within the flag itself up and down. So make it kind of wave. Now, at the moment, I can't really tell where my points are within the flag. However, what I can do on my mesh basic material is after the color, I can add a comma and say, well, let's press enter, wireframe is true. So here we see this in red, but we can actually see all the points of this instead now, even though it's spinning around in space. So by default, a plane geometry will just have one size each way. Now, what I can see in here is if I go back up and I open this little panel, is if I start to increase these numbers, there's going to be lots of different points within my plane that I can move up and down. At the moment, there isn't any points within this plane. There's no dots in here that I can move things up and down. So on my plane geometry, what I'm going to do is I'm going to increase the number of points on this. And to do that, I'm going to do comma and then say something like 15. There we go. We can see there's 15 going across now, comma 9. So 15 is just 5 times 3. 3 times 3 is 9. So this looks square. So what I can do within this now is move things up and down and move things out of my plane itself. Now, at the moment, this plane is moving up and down and spinning around because of this cube rotation. I'm just going to get rid of this for now. And this is just going to make it flat. So maybe I want to add a little bit of rotation into this to start with and then move it in and out. So at the moment, it feels a little bit too flat. I also don't want to call it cube. It's not a cube anymore. Maybe I'll call this flag, and then we'll add this flag to the page instead. Same thing, we're just changing the name. Let's just add a rotation onto this flag. So on the flag, let's going to add some rotation, dot rotation, and we're going to set this rotation to be, well, what? There's 3 ways I can change this rotation: 0, 0, 0. So X direction, Y direction, and outwards to the Z direction. Now, if I change the last one, so point, change it to 1, for instance, this rotates it around in this direction. Now, we don't want it to rotate in that direction. We want it to be flat. Maybe I want this bottom edge to be a little bit closer than this top edge. So to think about it, let's put some string onto this direction, onto this end, and we want to twist that string. So this string, I want this bottom end to go around in the X direction. So I want to rotate this slightly in the X direction. X, Y, Z. Let's just add 0.1, let's see. Now this is going the wrong way. The top is now rotating towards me, so it needs to be a negative. There we go. So this kind of has this pattern going out. What I want to do is for each of these points within the flag, where all of these kind of cross, I kind of want to move them around. At the moment, they're not moving around, of course. They're just flat. I'm just setting the rotation, and we want to move these points within the flag itself. Now, plane geometry is part of a general geometry class, and as part of that, it has things called vertices, basically points within it that we can actually change. So how do we want to change all these points? Well, basically, a plane geometry is just a quick way of writing a lot of this stuff out. What we're going to do instead is we're going to pick all these vertices, all the points within this flag, here, 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 quite a lot of them, and move them in and out. How do I want to move them out? Well, I kind of want to move them in this kind of pattern, this sine wave pattern. So move them in and out, but closer to the user in the Z direction, closer. So what we're going to say is, well, how do I animate all these points? Well, I'm going to animate stuff and basically say, well, on this flag that I've got, this mesh, there is a dot geometry. Now, at the moment, the geometry is a plane geometry, which has been made up here. On this geometry, I can get all of the points, the vertices. And then what I want to do is update them. So to update them, I'm going to map them, dot map. I'm going to run dot map and say for every single point, it's going to do something. So here, I'm going to say V goes and does some code. V points to some code. Now, here what I can say is things like, well, I want my movement to happen here. So which direction do I want all of these points to move in? Well, I want them to move them up and down closer to the user. So I'm going to change the vertices dot X. And instead, I'm going to make this equal to something. Now, at the moment, I could just say they're all 1. This moves it closer to the user. As you can see here, as I'm increasing that, it moves it further to the camera. 0 is where it normally is. If I make it minus, it goes the other way. Now I want them all to do something different based on what? Well, on my final one, what I have it based on is the X direction. We can see this X. If I go across this way, it changes how close it is to the user. So instead of this being a number, instead what I'm going to make it based on is something like math.sign. And in round brackets, I'm going to make it based on v.x. So here what we can see is this movement now. So this side and this side are very different. They're changing the direction of things based on the x direction. Now what I can say is this is always between 1 and -1. So for instance, I could say this is too close and this is too far away. So across all of this, I'm just going to say, well, maybe there's a bit of a limit to this. Maybe it should be 0.5 times this. It's a little bit flatter. If I make it even flatter and flatter and flatter back to 0, it gets really flat. If I make this really, really big, 2.5 times, it gets really close to the user, something like 0.5. Now within this as well, what I can say is this is the kind of size of the wave, this 0.5. But what I can also change in here is the amplitude, how many waves there are. So I can also say this Vx times something like 2. We can see now there's 2 waves. And I can increase this number of waves, and you can see how all this box starts to align. Now, the more waves that you have, the more segments you need. So for instance, at the moment I've got 15 and 9. Maybe I want this to be something like 50 and 30. So you can see here, now this is a little bit more defined. So maybe 6 is a little bit too much. Maybe 2 seems to work. There I've got that kind of flag moving around, and I have this kind of change. Now, of course, what I want to do is change this based on time. And at the moment, I don't have anything in here based on time. However, 3 has something called a clock that we can actually use. So what I need to do is make a new clock and then basically listen to how long the clock has been running for. So before any of this stuff starts, all this animate, I'm going to say constant clock. This is going to be equal to a new 3, all in capitals, dot clock. And then we're going to run that. So by default, the clock is not doing anything. However, in my animate, I'm going to add some space and say, for each time this animates, I want to get a progress of the clock. So here I'm going to say a constant called, let's call it t for time. And this is going to be equal to the clocks, or just clock, dot get elapsed time, round brackets. Now we're not using t just yet, but we want to put this in our code somewhere. So for instance, I could say, well, this x is the thing that moves. So I want to add t to this. Now at the moment, it doesn't do anything, and there is a reason for this. If we update the geometry, it will just freeze it in time until we say, hey, we need to update this. So as part of geometry itself, we need to scroll down, and in here, somewhere, deep in here, we need to update all the vertices. So we need to set it to true. So what do I need to set it on? The geometry. So here underneath this, on the flag itself, I'm going to say the geometry needs, what's it called? Let's have a look. Vertices need update. So I just got that wrong. Let's try that. Vertices need update equals true. And there we have something that moves. So what I'm going to do next is actually add layers on top of this. So at the moment, this is just one single wave. Instead, what I'm going to say for each of these things is I'm going to space this out a little bit and say, let's give it a constant called wave x1. So wave in the x direction, let's just have one of them for now. And let's just equal to all of this stuff that we had from below. I'm going to take this, cut it out, paste it in, and then replace it with wave x1. So this is doing the same thing. I just moved it to a constant for each individual point. However, what I can do now is add a second wave into this. So constant wave x2 and say, well, maybe let's do kind of the same as what we had here, just change some of the numbers. So here instead, maybe 0.25 times math.sine, and we'll do v.x times 1 instead of 2 plus t. Now we want to add these two things together to make two waves that run on top of each other to make it more natural. So here I'm going to add wave x2. So this is actually quite a more natural wave, and I can change some of this, maybe change that to 6. You can see this kind of like weird double wave and then a kind of miniature wave on here. Make this something like 3. It makes it look a little bit smoother. So I can play around with some of these numbers, and I can also play around with the time. Here, t times 2. So this miniature wave, this smaller wave, half as small as this one, runs on 3 in terms of the amplitude, and it moves twice as quick. So I have this more natural looking wave. I can also do this in the y direction as well. At the moment, I've done it on v.x. However, I could just say as well, I've got a constant wave y1. And instead, this kind of looks the same. So math.sign v.y direction now. And we'll add t to it as well. And we need to add this to the z direction. So notice now that this moves in this direction and in this direction. So adding them all together makes this kind of fluid movement. Now, of course, what I could do is say this y direction is way too much. Maybe let's make it 0.1. So this kind of looks a bit smoother across. Maybe I want to kind of times this amplitude. That's kind of how many waves there are by 5. So you can see there, I've got 3 kind of waves going this direction now. Maybe I want to slow down the time, so 0.5, so it doesn't move that quickly. But I have something that looks a little bit more natural now. Now at the moment, of course, this is just a kind of mesh. It's the wireframe. Wireframe is true. How do I get some images on this? Well, by adding this stuff in here, it makes it really easy to now just put an image on top of this. So what I can use as part of 3 is something called a texture loader. So how do we use this? Well, before any of this stuff starts, any of this geometry, what I can say in here is a constant called loader. And this is a new 3 in capitals dot texture loader. And then we run it. Now the loader isn't pulling anything in, but I've already got a few things in here that I can use. Something like a book.jpg or a flag.png. I've added these kind of stripes in just so we can see if it's moving rather than it be too flat. So let's try some of this stuff out now. Now instead of this wireframe being true, let's get rid of it. Now we have this red thing that kind of moves as a blob. Kind of hard to see what's going on, so let's add some texture. So here, instead of it being texture, I'm going to say the map of this is based on the loader, which is this thing up here, dot load, and in round brackets and in quotes, the name of the thing that we want to pull in. So for instance, book.jpg is our name. Now currently, you might notice this color is in red, and we've got some black areas on this. I can actually just remove this color now, and we have this moving. And I could just change this into something like flag.png, for instance, flag.png, to get something that looks like that. Now, one thing you might notice on my final design is this edge doesn't move, whereas this one does, trying to make it look more natural as a flag. Now, the way to do this is I kind of want to have a multiplier that starts at 0. So this has no movement, and this edge has 1. So 0 to 1. Now this edge is currently at minus 0.25. This is 5 across, and half of that is minus 2.5. So what I can say in here in my waves is also say, let's add in a multiplier, the multi. And this is going to be equal to, well, I want this edge to not move. So I want the Vx minus, well, it's not minus, it's plus 2.5, because this is minus. So the middle point minus the minus, and then let's divide all of this by the width, something like 5 is the width. And now I'm going to take all of this, put some round brackets on it, and times it by this multiplier. So this edge always stays the same, this edge always moves, and this is true of the y direction and the x direction as well. So by adding this stuff in really quickly, we can make this flag effect really well. And I can actually increase some of these numbers now and play around with that. Maybe it's a lot bigger. Maybe this is a lot faster as a wave, so it's a bit bigger like that. Obviously, I can try and play with some of the numbers and feel it out. But by adding a few bits of Three.js in here, we can actually piece together something that looks really professional and really impressive in just under 50 lines of code. So one thing you might notice is if I resize this, it doesn't actually fix anything. And there's a few ways that we're actually going to fix this. So the first thing you need to do is actually make the camera and the renderer fit to the section itself. At the moment, it's doing it based on the whole window, and we're just kind of lucky at the moment. At the moment, we have in here height 100% VH. If I just change this, for instance, to something like 50 VH, it doesn't change. So if I just quickly put a border on here, border of red, let's say, you'll see that my flag isn't inside the red area, it escapes. So let's just quickly fix this. So in my flag.js, instead of this being window width and window height, I can't use inner width. Instead, this is going to be the sections dot client width. and the section dot client, if I spell it correctly, client height. So this is going to fix the camera, because we're in the perspective camera. I also want to fix the renderer size as well. So same thing here. I'm just going to change this to not inner width on the window. It's the section dot client width and the section dot client height. There we go. Now the issue still of if we change this is still in effect. How do we need to do this? So at the bottom of my page, what I'm going to do is add a little bit of extra code. So down here, I'm going to say if our window, which is the whole of this area, we want to listen out and add an event listener to resize. If we resize the window, we want to run some code. So what code? Well, comma, function, round brackets, curly brackets. Whenever we resize this page, we want things to change. What do we want to change? Well, there's two things that we updated above. It was the renderer, we changed its size, and the camera as well. Now this is part of Three.js. This is something that is generally used on pretty much every project that you would use. So we're going to get this camera aspect ratio and basically say this is equal to what was here. So I'm going to take this code, which is the section client width divided by the client height. What I also need to do on the camera is say this has been updated. So similar to what we have here with vertices need update, I will need to update the camera by saying camera dot update projection matrix and then run this. Kind of a long one, but it still works. So again, you can see this camera changing size. You can see the thing getting longer a little bit there as well, but we need to also update the renderer too. So this one, pretty similar to what we have up here, the renderer set size. I'm actually just going to take this code on line 10 and put it in here. So now if I resize the window, you might notice this stays in the middle and looks pretty good no matter what size of the page I'm at. Again, I'm just going to quickly get rid of this so it's still full width. Going to get rid of my border and make this 100 VH, still in the middle of the page, and this fits nicely. If you're interested in learning more about WebGL and Three.js, take our experimental JavaScript course where we have 3 projects that cover this in detail.